Today, I want to take you into one of the strangest, most beautiful, and honestly, most confusing ideas in quantum physics. It's called the delayed choice quantum eraser. And to understand it, we must begin somewhere familiar. Imagine this. You fire tiny particles, photons or electrons, toward a wall with two narrow slits. Now something incredible happens. If you don't look at which slit the particle goes through, the particles create an interference pattern on the screen behind. A pattern of bright and dark bands, just like waves overlapping in water. It's as if each particle travels through both slits at once and interferes with itself. But the moment you try to measure which slit the particle actually used, the interference disappears. And suddenly, the particle behaves like a simple tiny dot. Two clumps, no waves, no mystery. This is wave-particle duality, the idea that nature is not fully wave and not fully particle until we look.
Then, physicist John Wheeler asks something shocking. What if we decide whether to measure the path after the particle has already passed the slits? Common sense says that's too late. The particle's history should already be fixed. But quantum physics says your later choice still matters. It's as if the particle never decided what it was doing until the measurement was completed. Time starts to feel less solid. Now we go one step deeper. We create two entangled photons, a signal photon and an idler photon. They are born together and remain mysteriously connected. The signal photon goes straight to a detector screen. The idler photon takes a longer, winding path to another set of detectors, where we can choose something powerful. We can either reveal which slit the signal used, or we can erase that information so the path becomes unknowable again. Here is the astonishing part. If the idler reveals the path, the signal shows no interference. But if the path information is erased, the signal's data, already recorded in the past, can be sorted to reveal a hidden interference pattern. And yes, the erasing choice can happen after the signal photon was detected.
This sounds impossible, like the future reaching backward in time to rewrite history. But physics gives a calmer answer. No real message travels to the past. No paradox appears. Nothing actually breaks causality. Instead, the two